Okay, today we want to look at using determinants and solving Cramer's rule, solving problems with Cramer's rule. So a determinant is a type of matrix operation that you can do. And if you have some matrix, let's call matrix A, B, C, D. Okay? If this is the matrix, all right, then the determinant of this matrix looks like this. Straight lines now. A, B, C, D. Straight lines. And what you do is you multiply this way. Okay, so that's going to be A times D. And then you multiply the other way on the other diagonal. And this is going to be B times C. And you subtract them. And that is how you find a determinant on a 2x2 matrix. So what does this look like with real numbers? Well, let's take the matrix 5, 3, 4, 1. And if I want to find the determinant of that, then I'm going to look at this 5, 3, 4, 1. And I'm going to multiply down on the down diagonal, okay, which is going to give me 5 times 1 minus, and then I'm going to multiply on the up diagonal, 3 times 4. And when you do this, you end up with 5 minus 12, or negative 7. And that is the determinant of our matrix. We'll call it matrix A. So the determinant of A is negative 7. The other thing that we can do with determinants is we can look at the determinant of a 3x3. So let's look at this determinant of a 3x3 matrix. We'll call it A, B, C, D, E, F, and G, H, I. If we look at this determinant, what we're going to do is, we're going to add our straight rows here. And A, B, C, D, E, F, G, H, I. But to do it by hand, what we need to do is we need to add 2 more rows. And so we're going to add the A, D, and G, 2 more columns, and then B, E, and H. Okay. And then we're going to do, just like on the previous one, we're going to have our down arrows. So we're going to multiply this way, and this way, and this way. Okay? And so what we're going to end up with is A, E, I, all multiplied together, plus BFG, plus CDH. Okay? And then just like we did on the 2x2, we're going to multiply up. So we're going to multiply this way, and this way. And what is going to happen is we're going to subtract, and then put a bracket here because we want to subtract the whole thing. And we're going to subtract G, E, C plus H, F, A plus I, D, B. And that's how you're going to find a determinant of a 3x3. So if we want to look at this in real life, let's take the determinant of a 3x3 with some numbers. 2, negative 1, 3. 4, 1, 0, and 3, negative 4, 2, negative 2. So if we want to take the determinant of this, then we're going to write this part down. And then add our two rows. So the first two columns again. 2, 4, 3, negative 1, 1, negative 4. Add those two guys again. Multiply down first. So we're going down this way, and down this way. That's going to give us 2 times 1 times negative 2 plus negative 1 times 0 times 3 plus negative 3 times 4 times negative 4. So there's the first guy. We'll go ahead and put all of him in brackets. Okay? And then multiply going up on the diagonal. 3 numbers at a time. You're in a 3 by 3 matrix, you got to get 3 numbers at a time. So minus, let's move all these guys over. So we're going to have 3 times 1 times 3 plus negative 4 times 0 times 2 plus negative 2 times 4 times negative 1. Okay? Combine all this down over here. So this is going to give us negative 4 plus 0 plus 36. Is that right? 3 times 4 is 12, 48. Which will give us 44 on the blue side. And then on the green side, we've got 9 plus 0 plus 8. Is that right? Negative 9. This should be a negative 3 right here. So this will make this a negative 9. So on the green side, we're going to have negative 1. And when you combine these two guys together, you get your 3 by 3 determinant. And it looks difficult and painful, but it is a pattern that occurs every single time. Okay? And that's all there is to it. Okay, so here's why determinants are really cool. We can use what's called Cramer's rule. So if we have a system of equations, ax plus by equals e and cx plus dy equals f, as long as the determinant does not equal 0. So if the determinant of our matrix does not equal 0, then the x-coordinate for your solution, the x-coordinate for the solution, is going to be the determinant of E, B, F, D, okay, over the determinant of A. And the y-coordinate for your solution is going to be the determinant of A, E, C, F over the determinant of A. Now you notice that the determinant of A is in the denominator, so that's why you have to not get 0. And also, if you'll notice, this determinant right here is missing the x column. The x column's gone, so that'll help you. And this guy right here is missing the, you guessed it, the y column. The y column's gone. So that'll help you keep your thoughts organized for your math. Okay, so how does this look? Well, let's take a problem like 9x plus 4y equals negative 6, and 3x minus 5y equals negative 21. And so now find the determinant of this. Well, what's the determinant going to be? Our determinant is going to look the determinant of 9, 3, 4, negative 5 is going to look like this. 9, 4, 3, negative 5. And you do your cross multiplying going down. So that's going to give us 9 times negative 5. And you're you're multiplying going up. So minus 3 times 4. Now we don't want this to be 0, so that's pretty important to look for and make sure we've got it right. We've got 45, negative 45, minus 12, which is negative 57. So we're good to go. Our determinant does not equal 0. And to find the x coordinate, all right, look at what we're going to do. We're going to take E and F, all right, so negative 6, the determinant of negative 6 and negative 21. And then the E and the F, that's the 4 and the negative 5. And we're going to divide it by negative 57. And then for the y coordinate, we're going to take the determinant of 9 and 3 and negative 6 and negative 21 over negative 57. Okay, so just determinants kind of all over the place. But that's not bad because these are doable determinants. They're not horrible. So again, we're going to multiply going down. We're going to multiply going up. And we're going to subtract those guys. Okay? So here's what we got. We've got negative 6 times negative 5 minus negative 21 times 4 over negative 57. And on the other side, we're going to have 9 times negative 2, or I'm sorry, 9 times negative 21 minus 3 times negative 6. And we're going to put all that over negative 57. So what does that give us then? That gives us negative 30 plus 84 over negative 57, which is that's plus 30, which is going to be 114 over negative 57. So x equals negative 2. On the y side, we're going to have negative 189 plus 18, which will give us over negative 57, which will give us negative 171 over negative 57, which lets us know that y equals 3. Now it looks horrible and it looks complicated, but it's not that bad. Once you get going, it's just a pattern. And that's how you use Cramer's rule.